everyone, so today we're going to discuss about dependent sources. So when we say dependent sources, these are voltage source or current source whose value depends on the voltage or current elsewhere in the network. So I have here two examples of dependent source circuit, and we're going to find the missing parameters. So our first problem, solve for the value of the voltage drop in a 500 ohm resistor. So our 500 ohm resistor is in the R3, so let's say this is our B sub O. And let's analyze the circuit. So we have here current I1, and let's say this is current I3. And by KCL, we can have the equation I1 plus I, the capital I, which is equal to 4I1 equal to I3. Now let's substitute 4I1 in our equation, and we'll have 5I1 is equal to I3. Next, we can have a loop here. So by KVL, let's start with 12 volts. Minus 1K multiplied by the current I1 minus 5 volts minus I3 multiplied by the 500 ohm resistor. And let's equate that to 0. But we have here 5I1 to I3. So let's just substitute it in this equation. And there you go. So we have here an equation that has only I1. So we have 7 volts equal to I1 multiplied by 1K plus 5 times 500. That's 3.5 kilo ohm, or I1 is equal to 2 milliampere. So now that we have solved for the I1, we can substitute this in the first equation. So 5 times 2 milliampere is equal to I3. Therefore, our I3 is equal to 10 milliampere. Now we can solve for our B sub O via Ohm's law. So 500 I3, or 500 times 10 milliampere. Therefore, our B sub O is equal to 5 volts. Now we can also check this by having the loop on the other side. Let's say 10 volts minus 625 times 4I1, the current that flows on that loop, minus I3 times 500 is equal to 0. So 10 minus 625 times 4 multiplied by 2 milliampere minus I3 times 500 is equal to 0. We can replace the I3 to 10 milliampere, and so we can check if our equation will be equal to 0. So 10 minus 625 times 4 times 2 milliampere minus 10 milliamps times 500 is equal to 0. So this will be 10 minus 5 volts minus 5 volts equal to 0. Therefore, our answer is correct. Now for our next problem, solve for the value of the voltage drop in each resistor. So we have to solve for the voltage drop in R1, R2, R3, and R4. Now let's say the current that flows here is our IT. Then the current that flows here is our I sub 3, and the current that flows here is the I sub 4. Now by KCL, we have I sub t plus I sub 1 is equal to I sub 3. So current in equal to current out. Then I1 is equal to 3I sub 2. Now we have this equation. but our I sub 2 is equal to 2 milliampere. So let's just substitute. So I sub t minus I sub 3 is equal to negative 0.006. So this is our first equation. Next, we have I sub 3 plus 2 milliampere or I sub 2 equal to I4, or I sub 3 minus I sub 4 is equal to negative 0.002. That's our second equation. Now by KVL, so we can have a loop here from 12 volts minus 100 ohm multiplied by the current that flows through it, which is IT, minus I3 times 20 plus 30, since they are series, minus I4 times 50 is equal to 0. Now let's just simplify this equation. You can have 12 is equal to 100 IT plus I3 times 50 plus I4 times 50 is equal to 0, and that's our third equation. So as you can see, we have here 3 equations, 3 unknowns, and we can just use our calculator to solve for these equations. So after using our scientific calculator, we can have I sub t is equal to 0.0565 ampere or 56.5 milliampere, and our I3 is equal to 0.0625 ampere or 62.5 milliampere, and our I sub 4 is equal to 0.0645 ampere or 64.5 milliampere. Now we can solve for the voltage drop of each resistor. So for V sub 1 to V sub 4, our V sub 1 is equal to 100 I sub t, or 100 times 56.5 milliampere, and that's equal to 5.65 volts. Now our V sub 2 is equal to 20 I3, and that's equal to 20 times 62.5 milliampere, and that's equal to 1.25 volts. Now for our V sub 3, that is 30 I sub 3, or 30 multiplied by 62.5 milliampere, that's equal to 1.875 volts. And for our V sub 4, that's 50 I sub 4, or 50 multiplied by 64.5 milliampere, and that's equal to 3.225 volts. So that's how we solve circuits with dependent sources.